Hello everyone, welcome to lesson 9-6, Analyze Data Distributions. In this lesson we will continue to address the question, how are patterns used when comparing two quantities? And we will look into the vocabulary, distribution, and symmetric. Let's do a quick vocabulary recap. Recall that in statistical displays, peaks, gaps, clusters, and outliers are identified easily. Complete the graphic organizer by matching the term with the correct description. This would be a good time to take note of these expressions. The first one, we have a gap. When you have a gap in your data, it's often an area with no information. So I can see here that we have a gap right down here where there are no data values. A peak. So if you think back to the area, or if you're considering data, think of a peak as a mountaintop. And this is often where you find the most data, the most information at its highest point. So a peak would be the most frequently occurring value or interval of value. So there we go. An outlier. I think a lot of you recall that an outlier is one piece of data that just doesn't seem to belong, one that sticks out or can be a fluke. Okay, and we can see that right here. It is a data value that is 1.5 times the interquartile range from the first or third quartiles, meaning it is farther out than our maximum or minimum. It's 1.5 times the interquartile range. And then finally, a cluster. And I'm sure you guys, simply based on the word, you can figure out that a cluster is a group of data grouped together. So when many data values are grouped together, right there. Like I said, this would be a good time to take note and make definitions for yourself. And again, how can we associate this vocabulary to a real world link? Well, by answering this question. Let's say you had a photo of a mountain range. Describe clusters, gaps, and peaks in that photo. I would say something along the lines of the trees cluster on the mountain. So we have a group of trees clustering on the mountain. The valleys represent the gaps. We have no data. And the tallest mountain is the peak. The tallest, the one where we have the most mountain, I guess, is the peak. When analyzing data, we can describe a distribution by its shape. So let's take a look at these two line plots and describe them simply by the shape they make. The distribution of a set of data shows the arrangement of data values. It can be described by its center, spread, which is the variation, and overall shape. Determining the symmetry of the distribution is one way to describe the shape. If the left side of the distribution looks like the right side, then the distribution is symmetric. As you can see here, the left side looks the same as the right side, so we can say it is symmetric or symmetrical. And this one has you can see that it starts to cluster between 6 to 8, and it's weighted more, or it's heavier on the right side. Here they say it's non-symmetric, or you can also say asymmetrical. So the left side looks like the right side, and on here the right side is taller than the left side. And as we've done in the past, another way to describe the shape of the distribution is to identify peaks, clusters, gaps, and outliers. If there is an outlier, the distribution is not symmetric. Let's have a look at example 1. Okay, here we have a graph. We look at the title and it says weights of adult cats. On the y-axis we're looking at number of cats, and along the x-axis we're looking at their weight in pounds. And we can see here that the peak is at 10 pounds. Okay, and it seems like we have a couple of outliers here, the 14, 15, nothing in 13, nothing for 6. Okay, so let's see what kind of analysis they've made. The graph shows the weights of adult cats. Identify any symmetry, clusters, gaps, peaks, or outliers in the distribution. The distribution is non-symmetric. Clearly it is non-symmetric. You see on this side we have 8 and 9 are equal, but 11 and 12 are not. We would need one more bar, possibly at 12 up to this level, and then 13 up to this level to make it symmetric. But even then we still have data for 14 and 15 pounds. So a couple of outliers. So it is non-symmetric. There's a cluster from 7 to 12 with a peak at 10. Okay, 7 to 12 with a peak at 10. There's a gap between 12 and 14, and there are no outliers. Okay, so they're not considering the 14 and the 15 outliers. Okay, possibly if the 15 was here by itself without the 14, then it would be considered an outlier because it's two spaces away. But I guess one space, one gap is not enough to consider an outlier, but it does make it non-symmetric. So now let's have a look at our example. We'll do this together, and I will make the notes in point form, and you will have to do the exact same in the guided practice and independent practice or skills practice. So make sure that you make good notes of the analysis I'm writing here in point form so that you can also do the same later. Okay, let's have a look. Identify any symmetry, clusters, gaps, peaks, or outliers in the distribution below. Here we have heights of students in inches. And we have a plot line from 58 inches all the way up to 72 inches. And it looks like we have a cluster from 60 to 63. We also have an outlier all the way here at 71. And there's no data between, so there's a gap between 63 and 71 and a peak at 61. Okay, let's organize that information in point form. I would start by saying the distribution is non-symmetric. And you can see that, okay, there is no symmetry. There is a cluster from 60 to 63, as we acknowledged before, with a peak at 61. There are gaps between 58 and 60, as you can see here, 58 and 60, and between 63 and 71. And for my last observation, I noticed there is an outlier at 71. So again, make sure that you are able to replicate this sort of analysis in your own answers. Okay, let's have a look at our second key point for this lesson. Now stick with me. I realize there's a lot to read here, but please try your best to pay attention as this is one of the pink sections, which is one of the key points of the lesson. So let's have at it. Describe the center and spread of a distribution. So the center and the spread, essentially the range. The shape of a distribution tells you which measures are most appropriate for describing the center and spread of a distribution. The mean and mean absolute deviation are affected by outliers, while the median and interquartile range are resistant to outliers, meaning they're not affected by outliers. Use the following graphic organizer to describe which measures of center and spread are most appropriate to describe a data distribution. So here we have, in the middle we have, is the data distribution symmetric? Okay, so we first have to ask ourselves, is the data distribution symmetric? Meaning, is it an even spread with a cluster in the middle, in the peak in the middle, right? So if it's not symmetric, then we use the median to describe the center and the interquartile range to describe the spread. Okay, where we choose what our first quartile is, the median, and the third quartile, right? If it's not symmetric. If it is symmetric, then use the mean to describe the center and the mean absolute deviation to describe The spread, remember the mean absolute deviation is how far does it deviate or vary from the overall average, from the mean. This would be something great for you to add to your notes. So please feel free to save the to pause the video and copy this down. It'll help you in the future. Okay, let's take a look now at example 2. Mr. Watkins' class charted the high temperatures in various cities. The results are shown in a line plot. So we have temperatures, and the temperatures seem to range from just under 76, so about 75, all the way up to about 105 or so. Okay? We have gaps. We have a gap there. We have a cluster here with a peak. And I don't think we have any outliers, unless maybe we can consider the 105 an outlier, but even then it's not very far from this 102 or so. So I wouldn't consider that an outlier. Is it symmetric? It is not. Okay? Because it is not symmetric, then the best measuring tool would be to use the median to describe the center and the interquartile range to describe the spread. So let's see. Describe the center and spread of the distribution. Justify a response based on the shape of the distribution. So again, we look at the shape of the distribution and we choose whether we use the median to describe the center and the interquartile range to describe the spread, or do we use the mean to describe the center and the mean absolute deviation to describe the spread? So which one are we going to use? Well, because it is not symmetric, we should use the median and the interquartile range. So let's see here how they answer. The distribution is not symmetric. We know that already. So the median and interquartile range are the appropriate measures to use. The data are centered around the median of 84. The first quartile is 80, and the third quartile is 95.5. So the interquartile range is 95.5 minus 80. So we're finding the difference, the full range within the interquartile, or 15.5. The spread of the data around the center is 15.5. Okay, 15.5 degrees is our unit. And this works best because it is not symmetric, and it doesn't matter if we have any outliers or gaps. This will be able to override any of that. Okay, and now we're going to try example 2 on our own, and that'll be it for today's video. As you can see, we have the guided practice following this example, so that means we will continue the rest in class. Let's have a look. The graph shows the hours per week that dance students practice their dances. Describe the center and spread of the distribution. Justify your response based on the shape of the distribution. Round to the nearest tenth if necessary. Number of weeks, number of hours. So they're both measuring time. Number of weeks and the number of hours. Okay, do we have a symmetric or non-symmetric distribution? As you can see, we do have a perfectly triangular symmetric shape. Okay, as we move out from the center, you can see that the data is matching. So it is symmetrical. We can also see that we have a cluster, a peak at 5, right? So this would be, because it is symmetric, the mean and mean absolute deviation are the appropriate measures to use. So let's write that down. We'll start by stating the distribution is symmetric. Therefore, the mean and mean absolute deviation are appropriate measures of use. And let's continue by saying the data are centered around the mean of 5 hours, as you can see, and the spread of the data around the center is about 1.2 hours. Again, I found this by finding the mean absolute value, okay, or the mean absolute variation, sorry. So what I did was I found the difference between all my numbers and 5 and then I found that average to give me my 1.2 hours. Okay, everyone, I really hope this made sense to you. Let's continue with the guided practice in person. See you then.